We are going to use method of trigonometric substitutions to evaluate this integral. So what we have here is that we have like our key component here is square root of 16 minus x squared. So when you have an expression in this form, then a Pythagorean identity suggests what? That just go ahead and make the substitution that x equals 4 sine theta. All right, because what will that do is this will change it to 4 cosine square theta, and then the square root sign will disappear. All right, so what you have is x is 4 sine theta, so dx would be 4 cosine theta d theta. All right, and then what we have is that 16 minus x squared is going to be square root of 16. X is 4 sine theta, so the square would be 16 sine square theta. All right, and what that gives us is that this will be square root of 16 minus 1 minus sine square theta. All right, so here we are. Okay, and then this becomes square root of 16 times cosine square theta using the Pythagorean identity. All right, now this would be 4 times absolute value of cosine theta. But here notice this, that theta ranges from 0 to 4. All right, so sorry, x ranges from 0 to 4. Okay, so what that will give us is that, see, when x is 0, sine theta is 0, so our theta would be 0. So as a consequence, theta ranges from 0 to, when x equals 4, theta will be what? Theta will become pi over 2. So since in the first quadrant the cosine is positive, and that's where we are looking at everything, so we can just simply write this as 4 cosine theta, right? Okay, so here our main thing was this, that is 16 minus x squared to the 3 over 2. So that simply becomes what that will become then? 4. Yeah, I hope I didn't make it more complicated than it should be. So cubed, and then here we have, cubed, and I'm just trying to write this here. This will be of this form, and then because of this would become 64 cosine cube theta, right? Okay, sorry, cosine cube theta. So what you get then is this, that the integral changes to, what does it change to? It changes to, see, the limits change to 0 to pi over 2 from 0 to 4. So let's write that down. So this is 0 to pi over 2. Okay, and then we have 64 cosine cube theta, and here we have dx as 4 cosine theta d theta. So we got 4 cosine theta d theta now, right? So this will be, so this integral is going to be, this equals, if we multiply 64 times 4, that will be 256, and then we have the antiderivative of cosine cube theta multiplied with cosine theta would be cosine theta to the power 4. Okay, now we have to just do one more transformation. That is, we have cosine theta to the power 4 and we don't have a factor of sine theta to substitute. But here we can remember this, we have double angle rules, and by them what we can do is that you can factor it as a factor of 2 squares of cosine theta, and then each of them is going to become what? A function in cosine of 2 theta. So it will just change to linear function. So what you have is this becomes cosine 2 theta over 2, and the second factor is the same thing. Okay, so if you FOIL these, what do you get? You simply get 1 plus, FOIL means we are multiplying these two quantities just by distributing and adding. So this will be 1 plus 2 cosine 2 theta plus cosine square 2 theta. Well, not to worry too much, because we have, seeing that we have cosine square here again, we can deal with that just with little patience. Okay, that is, notice this. Let me just write them factored out. So this is 1 over 4. Then for this term I will have 1 over 2 cosine of 2 theta. Let me write that in the parentheses. Okay, and then plus 1 over 4 cosine square 2 theta, right? So cosine square 2 theta. All right. Okay, so what you have is then that this integrand would be, that would be, you have all this the same. Okay, but in addition what you would have is that when we change it to linear, then we will relate to the angle double of this. So that will be 1 plus cosine of 4 theta divided by 2. So this integral that we have to evaluate, okay, what does that become then? That becomes the integral of, all right, let's just start adding terms here. So we get all these guys here, all right, and then 1/4 plus, and here will be 1/2 plus 1/2 cosine of 4 theta. So it will be 1 over 8, and then plus how much? 1 over 8 cosine of 4 theta, right? And now we are about done, as you can see. That is, this will be, let's combine 1 over 4 with 1 over 8. That will become how much? 1 over 4 plus 1 over 8 would be 3 over 8, right? Okay, and then go ahead and write the integral. Here I made a symbolic error or slip. Okay, so this would be, okay, just I think we are about done here. Okay, so this would be what? We will have simply, if we write the antiderivatives, then you can also see this will involve sine of 2 theta, this will involve sine of 4 theta, which will be 0 at both these limits, but still let's go ahead and finish it. Okay, so here we go. So we get 3/8 of a theta, right? Then plus cosine 2 theta. What's the antiderivative? It's sine 2 theta over 4 by substitution. Okay, or by now you have matured enough into this to realize it directly like that. And here it will be sine of 4 theta over 4. So that will be 1 over 32 sine of 4 theta. And now I'm just going to say something verbally, because knowing how well you have progressed into these techniques, is that sine 2 theta at pi over 2 is 0. Sine of 4 theta at pi over 2 would be sine of 2 theta. That will be 0. And at 0, both of these are 0, right? So these values will produce 0. Okay. So what we have is that this would simply become 3 over 8, right, times pi over 2. All right. Okay, pi over 2 or 3 pi over 16. Okay, so what that gives is, remember, we have to, our integral, this equals, right, this here, and then that is 256 times 3 pi over 16. All right, so multiply them out. What you have is that this equals 48 pi, if I didn't make any mistakes. So let's check. No, I didn't make any mistakes. Okay, so that's what the value of this integral is if we use the trigonometric substitution or that method. Okay.